While Dr. Gundry does support some healthy practices like fasting, it's important to realize that he's an Adventist. Seventh-day Adventists have a religious bias against meat, and they tend to support plant foods. Like some other big influencers, he also sells some very expensive supplements, so that also may color his outlook a bit. With the color green, if you catch my meaning.
$1 for eternal happiness. I'd be happier with the dollar.
Lately, I keep hearing about a molecule called Neu5Gc. There's so many nonsense topics out there that I didn't bother looking into it, but someone mentioned that it was part of the glycocalyx, and what was going on became pretty obvious.
So we found that there was a molecule, a sugar molecule, on the wall of pig blood vessels that's totally different from the sugar molecule that's in ours. But it differs by only one, actually, atom. And it's called Neu5Gc in pigs, cows, and lambs. And we carry what's called Neu5Ac. Well, it turns out that cancer tumors in humans use Neu5Gc to shield themselves from detection by the immune system. The problem is we don't manufacture Neu5Gc, nor can a cancer cell, which means they acquired it from external sources, namely beef, lamb, and pork. Now, fish doesn't carry it. They have the same molecule that we do, and chicken have the same molecule that we do. So I urge people, if they're going to eat animal protein, and I do, to use wild shellfish or wild fish as their main source of animal protein. Do I eat meat? Yeah, I mean, do I eat beef? I do. But I get grass-fed and grass-finished beef, and I use it as a treat, not as a mainstay of my diet.
That sounds pretty scary if you don't know what he's talking about. Cancer cells hiding from the immune system because you had some bacon? How terrifying. But what he's really talking about is the glycocalyx, which are a bunch of hair-like appendages, which are made of polysaccharides that line your blood vessels. The discovery of the glycocalyx is a relatively recent one, but it is actually a very important structure. As he said, it is partially there to let the immune system identify cells of your own body, but from there, things go a bit wrong. First off, cancer cells can and do use the normal human molecule Neu5Ac too, and they can make it themselves, or they can get it from the bloodstream, and Neu5Gc could also be made in mutated cancer cells. While Neu5Gc is not normally made in the human body, if you have a leaky gut, then you could be absorbing particles like this that are not really meant to be there. Thankfully, this one is perfectly harmless. The body can mistake it for the human version and take it into the glycocalyx. And if it does make its way to a cancer cell, then theoretically this could cause someone to have the cancer cell hide, but you have to keep in mind that the same thing also happens with the normal form of glycocalyx, the Neu5Ac. This is much like the people who claim autophagy causes cancer. It's true that cancer cells can trigger autophagy by mutating and use this to protect themselves from fasting in rare cases, but normally fasting is very lethal to cancer cells because they're unable to go into normal oxidative phosphorylation without being destroyed by apoptosis brought on by the mitochondria when they're supplied with enough energy to do so. Everything in the body is involved in some way with cancer, and it's easy for someone to choose something out to raise an alarm bell. In reality, most of these things are not causative at all. Dr. Gundry is worried that pork could cause cancer to be able to hide, but in reality, he should worry that high blood glucose will have this effect. How did that Neu5Gc and Neu5Ac actually get to the cancer cell? They almost certainly got there from damage to the glycocalyx from carb consumption. Simply drinking a glass of orange juice is enough to virtually wipe out your glycocalyx, and it takes about 12 hours for it to regrow. And when it is damaged, the bloodstream is completely flooded with these molecules, which any cancer cell is going to suck up into its body, and it can then use them to protect itself from detection.
So, glycocalyx, layer 1. Here it is, an electron microscope graph or photo, and it's pretty small, a couple of 100 nanometers. And here's a paper I'll just mention out of the many I got. Arterial glycocalyx dysfunction is the first step in the atherothrombotic process. That's kind of a strong title, and it was a very good paper, but it would be controversial because the first step is generally seen to be just LDLs going through the wall and getting stuck. So an interesting paper if you want to look it up. Here an outfit, and I'm not connected to them, did high carb meals in people to look at what happened to the glycocalyx. They didn't give full details, but I'm reckoning they were high sugar too. So there's the normal glycocalyx, 2 hours after the meal, 4 hours and 6 hours. And as you can see, there's a dramatic impact, no doubt about that. They noted that it takes the body 8 to 12 hours to fully recover up to the healthy glycocalyx. And of course, most people will be eating too regularly. They'll be eating high carb meals, and they'll be dropping another stone down into this pool within 3 or 4 hours. So you can probably guess the glycocalyx has a hard time of it.
Fasting is the best thing you can do for your glycocalyx, and the fewer snacks and meals you eat per day, and the lower the carb content, the more protected your blood vessels will be from glycation and other horrible damage that causes aging and ultimately cancer. Even so, I would not worry about this in the context of cancer. A high carb diet will make a situation where the glycocalyx constantly shoots out these particles that the cancer could theoretically use to hide from the immune system, but in reality they will always be available to some degree regardless of your diet. For cardiovascular disease, it's another story, because anything that encourages clotting and inflammation is going to help drive heart disease. But blaming these glycocalyx particles for cancer would be as nonsensical as blaming cholesterol for cancer. You could easily make a case that cancer cells are made of cholesterol, and how scary is that? In reality though, there's an inverse correlation between cholesterol and cancer. Cholesterol is a vital element of the immune system, and this is probably the main reason it is found in plaques in the first place. Cholesterol has also nothing to do with heart disease, and the medications that lower it have only a tiny benefit for a small subsection of the population whose bodies improperly clean up cholesterol. In one study, for 751 out of 752 people who take it, it's shown that the only change in health from taking statins is going to be extra side effects.
When you look at primary prevention, turns out the RCTs do not show any benefit on mortality. Do you know what the mean increase in lifespan is from treating high LDL with a statin is? 4 days. 4 days. None of these trials reduced CVD events, and some of the drugs actually reported harm. This just came out 3 days ago. And so you're looking here, at all-cause mortality, and this is the degree of LDL cholesterol reduction, and it doesn't matter if it's statins or ezetimibe or diet or anything else. That's your benefit. 0. On this side, we have number needed to treat. How many people do you have to treat with a statin to actually get it? One patient with benefit. 754. Ridiculous. Number needed to treat, maybe 10 might be cost effective. Really 5? might be cost effective.
Every doctor on Earth has heard of the P53 tumor suppressing gene, yet the vast majority of them have no idea what it actually is, and they've never heard of the Warburg effect. When this gene mutates, it triggers the Warburg effect, which is the fermentation of glucose for use as energy. This fermentation is similar to what yogurt bacteria do, and while it's very inefficient at creating ATP, it creates a great deal of byproduct material. This is dangerous because it actually turns this material into proteins and lipoproteins, which is what allows cancer to have runaway growth in the body. These cancer cells can use the nitrogen in the bloodstream to turn carbohydrate into protein, just like bacteria in yogurt and the soil. In fact, this is where all essential proteins, all essential amino acids, and all nitrogen fixation comes from. It comes from bacteria. Cows don't turn grass into essential amino acids. The bacteria in their digestive system turn it into proteins and saturated fat for their own purposes, and then the cow eat these bacteria. And this in a nutshell is why you can't starve cancer. Trying to deny resources to cancer cells is essentially impossible. You always have glucose and nitrogen in the bloodstream, and that's all that cancer needs. It can make anything it wants to, if it has the proper mutations. The little nutritional attention that cancer receives from the mainstream is all about starving cancer, and they mostly concentrate on trying to limit mTOR, that is, to limit protein, and things like that. This paradigm is doomed to failure, however, and it's actually going to backfire because you actually need the protein to fight cancer off. But thankfully, that's not how fasting actually helps with cancer, even though you might think it is. When you fast, it forces cells into oxidative phosphorylation, which means burning oxygen and then cleaning up the mess properly afterwards and turning the CO2 into water. This not only helps prevent cancer by reducing reactive oxygen species production, but it also gives the mitochondria extra energy. This is very important as it is the mitochondria that initiate apoptosis in malfunctioning cells like cancer cells. They just can't do this without that extra energy, and they can't increase mitochondrial growth either. While some cancer cells can make use of oxygen, doing so in this manner is often lethal if apoptosis is not triggered. Cancer cells will hoard nutrients like iron, and consuming large amounts of oxygen can produce so many byproducts that the cancer cell simply explodes from the inside. This is also how methylene blue and phototherapy can help with cancer. They both activate and energize the mitochondria, and they greatly increase oxygen usage. Fasting also affects the activity of phagocytes like macrophages, which fight cancer. And there's also microphages and several others that all have this activity increased. So don't think it's just your macrophages. It also regenerates these immune bodies, which become damaged over time, or due to safe and defective chemicals which are injected into the body. It also regenerates the thymus over time and releases stem cells which are required to make new T cells, which are crucial in the fight against cancer. Most people stop making these cells as a child, and when you run out, you're not going to like what happens.
What do we do? We die.
When you switch into autophagy, this also kills many cancer cells. That's because many of them have mutated to grow extremely rapidly, and once autophagy switches on, they can't sustain this rapid growth and they die. While some people claim autophagy causes cancer, the cancer cells that do use autophagy turn it on themselves. It's not turned on by fasting. Likewise, while insulin can help them grow, cancer cells often have hundreds or even thousands of insulin receptors. So once you have cancer, trying to control it with a low-carb diet is simply unlikely to be enough. Ultimately, cancer is a mitochondrial disease, When you eat a high-carb diet and consume linoleic acid, they combine in the mitochondria to make malondialdehyde, and this is a mutagenic toxin. It damages the mitochondrial DNA, and it leads to a state where large amounts of reactive oxygen species are produced by the cell, and they aren't cleaned up. This is the main substance that drives aging, and ultimately causes the mutations in the nucleus of cells that leads to the Warburg effect. Instead of relying on the bloodstream for oxygen to burn fat and carbohydrate, or even performing glycolysis without oxygen, which is damaging in its own right, now it's doing something much worse and behaving like a single-cell bacteria. It constantly pulls in glucose and nitrogen and other resources and turns them into whatever materials it needs to divide. You can prevent this to a large degree by eating a lower carb diet, but once you're afflicted with this ailment, that probably will not be enough to get rid of it. Fasting can also help a great deal to keep your mitochondria healthy, and so can methylene blue and phototherapy. You can even get mitochondrial benefits from cold exposure, but only if you actually shiver. You can even get these same benefits by simply standing on a vibration plate for 15 minutes a day. Now, this isn't my made-up pet theory, but one that has been around since the 1930s, which was discovered and promoted by Nobel Prize winner Otto Warburg. In more recent decades, this theory has been promoted by Professor Thomas Seyfried, who is one of the very few independent cancer researchers that isn't beholden to Big Pharma. He's had many amazing experiments which prove his case beyond any reasonable doubt, though still technically it's just a theory. This metabolic theory of cancer explains how so many random chemicals can all cause cancer, and it tends to appear only many years later. It all boils down to mitochondrial damage. For example, if radiation caused cancer from genetic damage to the nucleus, it would essentially instantly give you cancer, but that's simply not the case. If a cell is healthy, it is actually very good at repairing nuclear DNA, and when it can't do so, it'll cause apoptosis to occur in the cell. Instead, the damage to the mitochondrial DNA is the problem, and this leads to metabolic malfunctions over time, which makes the nuclear DNA unable to repair itself, and eventually you get mutations that can lead to cancer. To stay relevant and grow their customer base, influencers like Dr. Gundry have to constantly come up with new hooks. This is going to show people that there's someone with special insight who has knowledge no one else has, and that's what's going to get people to listen to them. Unfortunately, not all of them pan out, and the idea that Neu5Gc from eating red meat will lead to cancer just doesn't have any basis in reality. These big influencers also need to provide some special product you just can't get elsewhere. For Dr. Gundry, that is butyric acid supplements. And while short-chain fatty acids are important to the microbiome, the most important one is actually common acetic acid or vinegar. This is cheap and has endless benefits. While his talk about Neu5Gc is scary, cancer is a metabolic disease, and all the agents that cause cancer do so by causing metabolic dysfunction in the mitochondria. Healthy practices like a low-carb diet, fasting, phototherapy, methylene blue, and supplements like taurine, glycine, and alpha-ketoglutarate are going to have a great deal of effect when it comes to your mitochondrial health, and that is the best bet anyone has when it comes to avoiding cancer. Doing all this stuff may not turn you into a teenager again, but it should help you stay young at heart and to keep doing the things you love for many years to come.
Would provide for me, little one. What was I laughing at now? Oh yes, that crippled Irishman.